Hello, Shale Area. Welcome back for note video number 11. We're going to talk about compounds, and this is the first note video of part 3 of chemistry. So we're going to start working away from individual elements and begin discussing how these elements come together to make compounds. So the first thing to remember about atoms is that you have this nucleus in the middle. But a different atom's nucleus, they don't ever come in contact with each other because around the nucleus is this electron cloud. And the electron cloud is split into these layers. Now this would be the Bohr model of an atom. So in the Bohr model, we just have an electron cloud with these nice, simple to see rings, which is different from the most modern version of the atom, the one with Bohr, where these are in different shapes. So we use the Bohr model because it's the easiest to understand the chemistry about. So the other thing to keep in mind is if we have another atom up here, like if I had another nucleus up here and around it I had a ring, the nuclei don't touch. What ends up interacting with each other would be like if there was like an electron on there. Draw an electron, draw an electron. It would be the electrons in the outermost ring of this atom interacting with the electrons in the outermost ring of that atom. So if this atom had a second ring to it, and we stuck some more electrons in there, it wouldn't even be the ones in this ring. These electrons wouldn't even interact with this one. It would really just be these outermost electrons interacting with the outermost electrons of this atom. And that's how chemical bonds form. Chemical bonds form because of these interactions of the outermost parts of the electron cloud. And we call these the valence electrons. So you've heard that word before, but it's officially a vocab term now. And those are the only parts of the elements that interact with each other. All of interaction of matter happens because of these outermost electrons. So since it's the outermost electrons that are the most important when we're figuring out what kind of elements make molecules, we tend to only show those ones. And we do this through something called a Lewis dot model. It's called a Lewis dot model after a professor in college whose last name was Lewis, who first started teaching chemistry this way, and it really just kind of picked on. It's also just called an electron dot model. But what you do with these is you write the element symbol, and then you just put dots around it to represent how many valence electrons there are. So there are some already in your note packet, and there's 8 of them that are already shown up in your note packet there. So look at the 4 that come after it and see if you can figure out how many valence electrons they would have. Now you might say, how do I know how many valence electrons an element has? Well, that's what the periodic table is for. So if you remember, it has to do with the location in the periodic table. So if we have these ones, so sodium is here, magnesium is here, aluminum is over here, silicon is next to it, and then phosphorus and sulfur and chlorine and argon. So these are the elements here across the 3rd row of the periodic table. And notice their valence electrons. 1 electron goes with the first column, 2 electrons goes with the second column, 3 electrons goes with the third column. So it is the column of the periodic table, or the family that the element is in, that dictates how many valence electrons there are. So if you deduced correctly how many dots would go on these, I'm going to give you a couple seconds here to go ahead and look at the periodic table and figure out how many dots you believe to go on these and add them to the elements. Did you have 1 dot for lithium because it's in the first family, it's an alkali metal, 4 dots for carbon because it's in 1, 2, 3, 4th column, oxygen is 2 more, so it's at 6, and neon is one of the noble gases, so it has 8 in its outer shell. Notice how they are put on, by the way, because I see students do this in different ways. The best way to do an electron dot model is to keep them in pairs of 2 along the sides. So if it was completely full, you'd have 2 on this side, 2 on the top, 2 on the left, and 2 on the bottom. I see students sometimes they'll put like all 8 on top, or just do a couple here and then 6 over here. It's so much easier to look at and understand what's going on, especially when we start talking about bonding. Because when we start talking about bonding, remember, electrons bond in pairs. So if you remember from the happy atoms kits, like it takes 2 electrons to make a bond. So if you show them in groups of 2, it really helps the understanding in the next thing we're going to be talking about. All right, so if the dots represent the number of electrons in the outermost shell, or the valence electrons, remember here's a 3-dimensional Bohr model here, so you can actually see the levels or the spheres of the electron cloud. It's important to know how many electrons fit in these orbits. So the innermost shell, this one in here, is the smallest, and it's also the most high energy because it's the place that the negative electrons are the closest to the positive protons. So there's the greatest amount of attraction going on in here. These things are going super fast. So these electrons are zooming around, remember, at nearly the speed of light. Very few pieces of matter, if any pieces of matter beyond light itself, actually travel that fast. So they're zooming around here. Once you get 2 electrons in this inner shell, it's full. You can't put another electron in there. They're going so fast, they're kind of like everywhere at one time. I like to think of them as like the Flash, the superhero. They can run around, and he's like, if you ever watch the cartoons or the show, the TV show or the movies, it's like he can run around something and just kind of like hold them in place because he's everywhere in that path at one time. He's so fast. That's kind of what the electrons are like. So this whole shell in here is filled up with just 2 of them. But then when we get to the second shell and the third shell, the rest of these all hold 8. So the smallest shell is the one that has the most energy, and it holds 2 electrons, at which point it's full. The second shell can hold 8, and every shell after that can also hold 8. But every time you move away from the nucleus, you start in the middle, at this first shell, you move to the second shell, and then the third shell. Every step you take away, there's less energy involved because the negative electrons are further away from the positive nucleus. So there's less of an attraction force there. So the ones out here are held the most weakly to the atom. And that's really the secret to chemistry. Once you really start understanding this is the secret to understanding how molecules get made. That every element every atom wants a full outer shell. If it has a full outer shell of electrons, then it's happy. It's the most stable. It stops going and looking for other electrons. Not that it's really looking for other electrons, but it stops interacting with other atoms if its outer shell is full. So if you can remember 2 and then 8, 8, 8, 8, 8, then you're in good shape. Now, when you get to the high school, they're going to change that rule a little bit, because when you start talking about those transition metals in the middle of the periodic table, things start to change. There's other stuff going on that has 10 electrons in it, but we'll wait for that for the high school. So the first row of the periodic table contains hydrogen and helium. So we have our hydrogen, and then this is our outermost shell because it's the first ring, and it holds 1. Helium holds 2 electrons, and now it's full. This is why we jump to the next row, because every row in the periodic table represents the filling of one of the shells in the electron cloud. So now sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, and argon. These are the same things you just saw on your previous page of notes with just the electron dot models. Notice sodium had 1. Well, there's 1 electron in its outermost shell. Magnesium had 2 dots in the Lewis dot structure. Well, there's 2 electrons in its outermost shell. So this is the same exact setup, but it's showing the entire Bohr model of the atom instead of just the Lewis dot structure. So we have 2 electrons in the first shell, we have 8 electrons in the second shell, and then 1 left over. Now the number of electrons is equal to the atomic number. So you can fill these in, you can fill these Bohr models in several different ways. You can look at the atomic number, know how many electrons there are, and then just start filling them from the inside out. I'm going to put 2, and then I'm going to put 8. Oh, but it's got an atomic number of 11, so it has to have 11 electrons, so that last one goes on the outside. Or you can use its position. I know sodium is in the first column, so it's going to have 1 in its outermost shell. You just stick 1 right there. And we know if it's going to have 1 there, that the second shell is going to be full, so it's going to have 8. We know this first shell is going to be full, so it's going to have 2. Lots of different approaches to this, which you use whichever one makes the most sense to you. So, quick check question. Put the dots on here correctly, and that'll be the one that we do in class. There's a couple more examples here. So we have first shell, hydrogen, helium, and then that big gap in the middle. That's why that big gap there is in the middle. Remember, one of the objectives of the chemistry unit is to be able to explain why the periodic table is the shape that it is. Well, that's because of the structures of the atoms. You have that big jump in between because all the elements in the first column only have 1 electron in their outermost shell. That's why hydrogen's over there. It only has one in its electron cloud, or 1 in its valence shell. But I also discussed how you can also put hydrogen in the 7th column because, yes, it has 1 in its outermost shell, but it also only needs 1 more to fill its outermost shell, and that's what all of the ones in the 7th family have in common. They have 7 electrons in their outermost shell, but that also means they only need 1, and that's why they're so reactive, because they're so close to having that full outer shell that they just yank any electrons that they can off of anything else that they can find. And the reason fluorine is the most reactive of all of them is because that spot that's open that needs to be filled is closest to the nucleus, which is positive. Remember, the closer you get to the nucleus, the more energy that there is in that connection. So while chlorine also only needs 1 in its outermost shell, it's further away from the nucleus than it is with fluorine. So yeah, it's still going to rip things off, and it's still going to, steal that electron from something else to fill up that shell, but it's not going to do it as vigorously. It's not going to be as devastating as fluorine would be. Now, it's still nasty stuff, and this is also why these tend to be very toxic, because it's very easy for these things to pull the electrons off of, say, atoms that we're made out of. And that's why chlorine will do things like burn you if it gets on you, and bromine will burn you if it gets on you, because that's what it's doing. It's kind of ripping all those electrons off and creating a ton of heat and just dissolving your flesh as a result. It's not good. Not good to get those on you at all. That is the end of this first note video of part 3. We got 10 questions, a couple more note videos to go, and we'll be all done with chemistry. Have a great day. See you in class.